Yes, hello everyone. So we are going to discuss a question based on river crossing. But again, is it really a river crossing question? Let's see. Let's read the question. To cross a river of width b equal to 320 meters, a boatman steers his boat always aiming towards a point that is directly opposite to the starting point. Velocity of the boat relative to the river current is given as 2.5 meter per second. Okay, and the river current velocity is given as 1.5 meter per second everywhere. It's a constant. Determine the time which the boat will take to cross the river. So first of all, according to the given question, what we understand is that we have actually a river and a boat is trying to cross this river. Okay, and what they have said here specifically, the boatman steers his boat always aiming towards a point that is directly opposite to the starting point. So that means the boatman from here would try to steer in this direction with velocity of boat with respect to water with this velocity, and then the river or the water will push it in this direction. So this is velocity of water, and finally the man would be going in this way, right? So what the question is saying, the it always steers, the man always steers in the direction towards the starting point. So I will be trying to draw this in a different way. I'll say that at this moment, at this current moment, the boat is having a velocity in this direction with respect to water, and the water at this exact point is having a velocity in this direction, which is vw. After some time, the boat has reached, let us say, somewhere here. Okay, and then again the boat will not be actually reaching here, right? Because of these two velocities, the boat would be having a resultant in this way, and the boat might reach somewhere here after some time. Now because the boat is here and the point is here, the man would be steering the boat in this direction, and again velocity of the water will be in this direction. This is vbw and this is vw. Now because of this, the resultant would be along in this direction and the boat will go here. Now again you can see that this will be the new velocity of the boat with respect to man, and this will be velocity of the river. You can understand the boat would do this kind of a journey, and somewhere here you can see the velocity of the boat with respect to water has bent this much, and velocity of the water is remaining in same way, and finally the boat will be reaching here. This is how the journey of the boat would be with respect to ground. So with respect to ground, this is how the boat would be moving. As an observer on the ground, I'll see this way, right? Now they're asking me to find out the time taken here. So it won't be an easy task because my angle theta, that is the velocity vw, is keep on rotating, and finding that theta at different moment itself will be a challenge. So basically I'll have to do some integration, create some relationship for the theta, then I'll have to solve this, a difficult task, right? But there's a trick here. The trick, it's a very fantastic trick actually. This is where you feel that importance of the what you can say, the concept of reference frame. If you just change your reference frame, let us not be looking at it with respect to ground, but let us look at it with respect to river. Let's look at it with respect to river. With respect to river, when I see, I'll be assuming that the river is remaining constant. River is not moving, river is stationary, but everything else is moving. That means the point A, or this point which I'm calling as the bank, let us call it as a name A, and this let us call it as B. So the point A, which normally is stationary with respect to ground, but if you imagine yourself as an observer with respect to river, then this point A would be moving in this direction with the velocity of the water, correct? Because water will remain stationary for you, and it looks like that the point A, that port, is moving backwards with a velocity vw. And what is the velocity of the boat? The velocity of boat will be the same, that is vbw. Now try to think what is happening. The river is stationary, this one is moving, the port is moving left side. So after some time the port has reached here, the boat has reached here. So now the boat would be steered always in the direction of that port. So the boat is now moving in this direction. So after some time the boat is here, but now this boat has moved further ahead, the port has moved further ahead, and it has reached here. So now again my boat has to change its direction, it'll again go in this way, again the port will come in here. So I hope you are able to understand, it is moving in a particular path. That path I can show by using this blue colored line. So my boat would be moving in this kind of a motion, and finally it will be meeting with my boat, with my port at some location. The boat and the port, both of them would be meeting after some time somewhere. Now, which topic does this look similar to? Those of you who have watched my video, you will know that we have already discussed a topic called as dog chasing cat. Okay, already I have uploaded a video, make sure to look at this. I will make sure to put that video in the description. Watch that video, understand that dog chasing cat concept is exactly same. The boat here is behaving like the dog, and the port here is behaving like the cat. So, and we have directly a formula, a derivation has been done there, and we get a time formula. The time is equals to v into d divided by v square minus u square, where what is v? V is the speed, the constant speed of the dog, and u is the constant speed of the cat, and d is nothing but initial separation. Initial separation. That's it. Okay, so just repeat that here. What is the initial separation? In the question they have said that this distance is something like b, right? And how much is that b equal to, they're saying? Let me look at the question. In question they are saying that b is equal to 320 meters. This is 320 meters, and the velocity of the boat with respect to river is 2.5 meter per second, and the velocity of the river is given as this is 1.5 meter per second. This is the data given. So using this, now I'll be able to solve it. Velocity or the speed of the dog corresponds with this. The boat is the one chasing it, the port. So I can say the boat chases the port with a speed of 2.5. For what distance it is chasing? It started with a separation of 320 meters divided by, again this is 2.5 square minus 1.5 square. Okay, so this can be now written as 5 by 2 times 320 divided by 2.5, this a square minus b square formula, 2.5 plus 1.5, it will become how much? 4, right? And 2.5 minus 1.5 will become equals to 1. So I am having now 4 and this, so we can write it as 8 432 and a 0. Then I'll be having this multiplied as 40. 5 into 40 comes out to be 200 seconds. So we can say in a time of 200 seconds the boat will be catching the port, just like the dog catching the cat. Okay, so very simple question if you understand the concept of reference frame. Otherwise, if you imagine solving this, how lengthy it would have become. But the moment you change the reference frame, you understand the question comes under the category of dog chasing the cat, and very easily, we already know the formula, very easily we'll be able to solve it and get the answer. I hope all of you have understood. We'll stop here. Thank you.